Hi folks, Dr. P here. Here is a question that I got from a student. This is from Combinations and Permutations, question number 23. Okay, so we have a group of 4 journalists is to be chosen to cover a murder trial. There are 5 male and 7 female journalists available. How many possible groups can be formed consisting of 2 men and 2 women? So the first question you have to ask yourself, does order matter? Does the order in which we choose these 2 men matter? Or does the order of the 2 women that we choose matter? So this is an example of, so if the order matters, it would be a permutation problem. But here the order doesn't matter. It doesn't matter which man is chosen first versus second, and same for women here. So if the order doesn't matter, it's a combination problem. Okay? And the word "and" in this context here refers to multiplication. Okay? So to the number of combinations that we have for choosing 2 men out of 5 men available would be 5 choose 2. So these are the men. So these would be 2 men, 2M. And then we also need to choose 2 women, so 2W. So here we have 2 women that we choose from a total of 7 females. So it's going to be 7 choose 2. So we're choosing 2 men and 2 women, which means we have to multiply. So it's going to be 5 choose 2 times 7 choose 2. 5 choose 2 is 10 times 7 choose 2 is 21. This is 210. So 210 different ways that we can, or possible groups that we can form if we want them to consist of 2 men and 2 women. Right? In B, now we want the number of possible groups consisting of at least 3 men. The term "at least" means that the group will consist of 3 men or 4 men. Okay? So we can write this as, we can have either 3 men. I don't use red. So the group can consist of 3 men, 3M, or, well, actually, hold on, I'm forgetting something here. If there are 3 men in the group, right, there will be 3 men, and because the group consists of 4 journalists, it will be 3 men and 1 woman. So that's one possible outcome. Or we can have 4 men and no women. Okay, so 3 men from 5 males is going to be the number of possible arrangements. It's going to be 5 choose 3, and still represents multiplication. And 1 woman is going to be 7 choose 1. Or means plus. So this here is going to be the number of possible groups with 3 men and 1 woman. But the question doesn't say 3 men and 1 woman. It says at least 3 men. So that's why we have to add the number of possible groups that only consist of men, 4 men. And this is going to be 5 choose 4. So 5 choose 3 is 10. 7 choose 1 is going to be 7. Plus 5 choose 4 is 5. 10 times 7 is 70. 70 times 5, 10 times 7 is 70. 70 plus 5 is 75. So 75 possible groups. And finally, we have the number of possible groups that can be formed consisting of at least of at least one woman. So let's write down the options that we have here. Well, we can have a group that consists of one woman. And if there is, that's not really clear. So we can have a group that consists of one woman. And if we have one woman, that means that we also need one woman and we need the rest of the group will be men, so 3 men. So that's one possibility. Or, because it says at least, we could have a group consisting of 2 women and in that case it's going to be 2 men. Or we can have 3 women and 1 man. Or we can have a group consisting of 4 women and no men. Okay, so let's translate this into mathematical notation. So 1 woman, so there were 7 women, so it's going to be 7 choose 1 times 5 choose 3, or means plus. It's going to be 7 choose 2 times 5 choose 2 plus, and then we're going to have 7 choose 3 times 5 choose 1, and finally plus, and finally 4 women. The number of possible groups consisting of 4 women is going to be 7 choose 4. So this is a bit of a longer expression, but if you break it down like this, first describe the possible group compositions, right? So we have these 4 possible compositions. Okay, put in the words and or, where and will always represent a multiplication and or will always represent an addition. And then you translate it into, well, in this case, it's going to be combinations because order doesn't matter. Okay, if order matters, it's going to be permutations. So 7 choose 1 is 7. 5 choose 3 is 10. 7 choose 2 is 21. So you'll have to do this on your calculator. 5 choose 2 is 10. 7 choose 3 is 35. 5 choose 1 is 5. And then finally 7 choose 4 is 35. Okay, and if you evaluate this whole expression here, you're going to get 490 possible groups. All right, I hope that helps. Until next time, take care.